So for 6.3, day 2, we are still going to be talking about roots, but we are also going to be extending this to rational exponents. Okay, so we're going to be doing some simplifying. The first thing we need to remember is what a rational exponent is, and a rational exponent is just going to be a fraction. So a rational number is a number that can be written as a fraction. So whenever you see the word rational, I want you to think fractional. Okay? All right, so there is an exponent 1 over n, and that indicates the nth root. So whenever we are trying to find our root, if we have a variable a to the power of 1 over n, that is the same thing as taking the nth root of that value. Okay, so they give you an example here. If you had 16 to the 1/4, that would be the 4th root of 16, and that does simplify. It's a perfect 4th root. Okay, so for a to the 1 over n, you can apply that. So what we're going to do is write out what we have for a to the 1/2, a to the 1/3, a to the 1/4. Remember from our conversations yesterday, if the index is 2, you don't write it. It's a square root. So this is just the square root of a. If you have a cube root, you are going to write your index number. It goes right here in the radical. Don't put it on front. Don't put it on top. Okay, it goes right there, that little nook. Okay, and then we can also extend this if we have a fraction where the numerator is not 1. Okay, so we're going to talk about this exponent, m over n. It means the nth root raised to the nth power. Okay, it's the nth root raised to the nth power. So what that means is the denominator of the rational exponent, that's the n value, okay, the denominator becomes the index of the root. Okay, so when you have a to the power of m over n, there's 2 ways that you can write this. Okay, so the denominator is the root. Okay, so it's the nth root of a. And then here it says it's raised to the m power. So there's 2 ways you can do that. Okay, you can put the m power on the outside, or you can put the power on the inside. Okay, so both of those are going to be acceptable cases. Okay, so power can be applied inside or outside the radical. Okay, your power can be applied inside or outside your radical. Now, because we aren't using a calculator, a lot of times it's going to be easier for you to do the power second, so outside the radical. Okay, so you're going to have that option, but sometimes we are going to need to apply it inside, and I'll show you those cases today. I'm always looking for ways that I can remember, like if I'm taking a test or a quiz and it's something where you don't want to be able to look something up. How can I remember which is which? How can I remember what's the root and what's the power? And what has always worked for me is remembering a tree root. right? If you have the root of a tree, where do those grow? In the ground. Yep, underneath. So that's going to be roots grow in the ground, so they're on the bottom. Okay? And if you're at the top, like if you're the CEO of a company, you have the power. Or I draw a little crown, my little king's crown here. Got some gemstones on it. Okay, so what I remember is roots grow in the ground. If you're on top, you got the power. All right, so you can use that if you wish. So what we're going to do today is we're going to write expressions in radical form. We are going to be simplifying if we can. So starting with part A, we have x to the 3/4, and for B, we have y to the 1/4. I would like you to write those in radical form based on the concepts we just talked about. So if you are writing in radical form, you should see a radical in your answer. Okay, so A really has two possible solutions. You can either write this as the 4th root of x, all raised to the 3rd power, or you can write it as the 4th root of x cubed. Okay, either one of those are correct. Okay, for B, it's just the 4th root of y. All right, now for C, you are going to have parentheses. So you have 2xy all to the power of 2/3. Whenever you have parentheses, that means you are going to have to apply that fraction to everything that's inside of it. And so when we do that, okay, we're going to make a radical. So we're going to do the 3rd root. And then everything inside 2xy has to be raised to the 2nd power. So there's going to be some work with parentheses here that might be a little bit tricky. Just remember, if it's inside the parentheses, you are going to distribute. So when you distribute, you have 2 to the 2nd power, that's 4, x to the 2nd power, y to the 2nd power. There's nothing you can simplify here. Okay, there's no group of 3 you can take out with any of them. So then this is going to be your final answer. All right, now D is a little bit different. So I want you to notice a few things. From C to D, we both have parentheses. Both of them have a fraction. Okay, but do you see how this fraction is less than 1 and this fraction is greater than 1? Remember what if it's greater than 1, what type of fraction it's called? I know, it's called improper, which I feel like is kind of rude. It's improper. Okay? The name implies that it's not right. But improper fractions are okay here. It's just if you have an improper fraction, that means your value is greater than 1. You're going to be able to simplify your radical. Okay, so this one we're going to tackle a little bit differently because of that. So what we're going to do before we rewrite it like this, and you could do it this way, okay? There's multiple ways you could do this. You could start out and do that, but if you did, you'd have to do 27 to the power of 4. That's gross without our calculator, right? I don't want to do that. So instead, what we're going to do is we're going to distribute. So it's 27 to the 4/3 times b to the 4/3. And the reason why we're going to do that is so that now we can do the cube root of 27 and we can raise that to the 4th power. We can put the 4 on the outside. And we're only doing that because there is that improper fraction, okay? So the cube root of 27 is what? 3. 3 to the 4th is 81, okay? And then for b to the 4/3, that's just going to be the cube root of b to the 4th. And then we're going to apply what we learned yesterday. Okay, so we simplified here. 3 to the 4th became 81. Here we have b to the 4th power underneath the cube root. So 3 goes into 4 one time with 1 left over. So when you multiply those together, you have 81b times the cube root of b. And that's going to be your final answer. Okay, so because this was an improper fraction, we could simplify that radical. If you have a fraction that's less than 1, you won't be able to take anything out of it. Now the directions in the next one say to write each expression in radical form and simplify. So it's going to be very similar to what we did above. And when you're simplifying, you just have to make sure if you have any perfect values that you're taking those out. Okay, so I'm going to let you try A and B. If the first one's giving you a little bit of pause, feel free to do first, that's fine. B is easier than A. Okay, so when you're deciding where you should put the exponent, okay, ask yourself if you want to do 32 to the 3rd power, because I would not want to do that. Okay, so if it's a very large number, then start off by doing the 5th root of -32 and raise all of that to the 3rd power. Okay, when you have a negative, if it's an odd root, that's okay. What does that just mean about our solution? It's going to be negative, yeah? Okay, so it's going to be a negative value to the power of 3. Okay, some of you might know the 5th root of 32 right away. Some of you might need to factor tree. Okay, whatever path you're on, that is fine. Okay, 16 is 4 and 4. That goes to 2 and 2. So you have 1, 2, 3, 4, 5 2's, which means the 5th root of -32 is -2. And -2 to the 3rd power is -8. So that's going to be your final answer. Okay, so 2 to the 5th is 32. So -2 to the 5th is -32. And it's okay to have a negative with an odd root, because if you multiply a negative an odd amount of times, you do get a negative. Okay, again, just like yesterday, you won't have any negatives inside an even root, so you won't have to worry about imaginary numbers here. Okay? All right, and then we're going to do the cube root of 64. Some of you are going to know that right away. What is it? 4. Again, if that's not something that you look at and know right away, you have options. You do know that 84 is 8 times 8, and you do know that 8 is 2 cubed, right? So if you have a group of 3 2's, a 2 comes out. You have another group of 3 2's, a 2 comes out. 2 times 2 will be 4. Okay, whatever you need to get yourself to that final answer is fine. All right, now C is a little bit different. We have 4x to the 5 over 2. So in the last one, we talked about this. If you have an improper fraction, okay, then we should split these up and distribute. So that's the first thing I want you to do. Okay, it's an improper fraction, so distribute. Okay, and then you can check to make sure you did that first step correctly. You have 4 to the power of 5 over 2, x to the power of 5 over 2. So 2 means you have a square root to the 5th power. Are you guys able to do that? And what's the square root of 4? 2 and 2 to the 5th? 32. Okay? Now for this one, again, the bottom's the root. So this is the square root of x to the 5th. So, yep, we're going to simplify just like we did here. So you ask yourself, how many times does 2 go into 5? 2. So x squared comes out. So if it goes in there twice, that's because 2 times 2 is 4. So if you subtract 5 minus 4, you have 1 left over. So your final answer is going to be 32 x squared root x. All right, I'm going to write it without the multiplication in there. So 32 x squared root x. That's going to be your final. All right, now we have 625, and let's look at our exponents. So we've been working with fractional exponents, but we've also seen negative exponents before. So if you have a negative exponent, how do you make it into a positive? Yeah, how do you make the negative into a positive? Yep, you're going to put it under 1, and then you change your exponent to a positive. Okay, so our first step is just going to be 1 over 625 to the 3/4. Okay, if you need to write yourself just a little reminder that this is the rule, you can write that in there as a reminder. That's your negative exponent rule. And then from there, we're just doing what we have been. We're going to do the 4th root of 625 to the power of 3. Yeah, 625. What goes into 625? 5. Okay, so we can divide that. Okay, 5 goes into, how many times does 5 go into 60? What? Okay, I thought you said 40 for some reason. 5 goes into 60 12 times with the 2 left over. 5 goes into 25 5 times. Okay, and some of you might even know, because 625 is a perfect square. What's the square root? 25. So you could do 25 times 25 as well. And then we should all know that 125 is 5 cubed. So there's 1, 2, 3, 4 5s. Okay, which means if you take the 4th root, you're going to be left with 1 over 5 cubed. 1 over 5 cubed is 1 over 125. Okay, so that number was a little bit bigger, but that's still doable. If it ends in a 5, you know 5 has to go into that. Okay, so you can divide to find that if needed. Okay, now the directions for the next one are different. It says write each expression using rational exponents. Okay, don't get radical and rational confused because they are similar. So if it says a rational exponent, Remember, that just means you're going to have a fraction in it. Okay, so we're going to be going backwards now. So you have the 8th root of 13 to the power of 4. Here you have the 5th root of x. Okay, and honestly, b is easier, so let's just start with that one. Bless you. Okay, so this is exactly like what we were talking about above. If you have the 5th root, right? If it was the 4th root, it was the 1/4. Cube root, 1/3. So the 5th root is going to be x to the 1/5. And that's it. That's all you're going to have. X to the 1/5 power. Of course not. Okay, so let's go back to A. Okay, so you start with your radicand, and then you just have to write your fraction. So on the bottom of the fraction is the root. So on the bottom of our fraction here, we have what? 8. Okay, the top is the power, so it's 4/8. If you can reduce your fraction, you will. So 4/8 is 1/2, so it's just going to be 13 to the 1/2. Okay, so if you can reduce your fraction, you're going to reduce the fraction. Okay, they're not always going to be able to be reduced. Sometimes they're already reduced, and that's okay too. Okay, now both of these had only one value underneath. In part C, our radicand has a 9, an x squared, and a y cubed. Yes, please. 9x squared y cubed. Okay, so when you have more than one term, you are going to put everything in parentheses. 9x squared y cubed. Okay, and just like we did here, the 5th root is 1/5. The cube root is going to be 1/3. And then we're just going to distribute the exponent. Okay, so if we distribute the exponent, don't forget the number. So we're going to start with 9. So it'll be 9 to the 1/3 power. If you multiply exponents, do you remember what you do with them? So a power to a power, you're going to multiply. So 2 times 1/3 is going to be 2/3. And what is 3 times 1/3? 1. So if it's to the first power, you can just leave it. Okay, so y to the 3/3 is the same thing as y to the first, which is going to be y. Okay, we are going to review some of those exponent rules that are going to help you. Okay, so there is a table on the back that already has some examples in it. Those are just extra examples to help you if you get stuck. Okay, we're going to do some examples together. So in words, we're doing the product of powers property. The algebra is if you have the same base and you're multiplying, then you are going to add your exponents together. Okay, so you're going to add your exponents. If you divide, you are going to subtract your exponents. Okay, and they have to have the same base. Okay, so we're going to do an example. 5 to the 1/2 times 5 to the 2/3. And 3 to the 2/3 divided by 3 to the 1/3. Okay, so I want you to set up the first step for each of those. You have the addition, you have the subtraction. Okay, so your first step in the first one is just writing down that you're going to add 1/2 and 2/3. Okay, we need to remember our fraction rules. If you are adding fractions, what do you have to have? Common denominator. So for 2 and 3, your common denominator is 6. So to get there, you just have to multiply. So to get to 6, I'd multiply 2 by 3, so I multiply the top by 3. To get to 6, I multiply the bottom by 2, so I'm going to multiply the top by 2. Okay, so this is going to be 7 over 6. Don't get it twisted, 7 over 6. Okay, and then the 2/3 minus the 1/3. Now that one's nice because you already have a common denominator, right? So it's just going to be 3 to the 1/3. Yep, so 2/3 minus 1/3 is just going to be 1/3, so you're just going to leave it. Nope, nope, it's a power. Yep. Okay, and then the next one is going to be multiplication. So a power to a power, you multiply the exponents. So when you multiply, you can have something like this. 27 to the power of 1/2 to the power of 2/3. 27 to the 1/2 power to the 2/3 power. When you have fractions and you're multiplying, all you have to do is multiply the numerators and the denominators. So 1 times 2 is 2, 2 times 3 is 6, 2 over 6 is 1/3. Remember that the 1/3 is also the cube root, and for this one, 27, it's a perfect cube. What's the cube root of 27? 3. So we would simplify that if it's perfect. Okay, 3, the cube root of 3, that's not perfect, so you wouldn't have to worry about that. You multiply. So 1 times 2 will be 2, 2 times 3 will be 6. So you're just going to multiply your fractions together. So there is a lot of fraction review in here. Yep. Okay, now for one like this, you're going to distribute your exponent. And when you're distributing the exponent, generally they're going to make the numbers more workable. But some of the numbers for this are going to be, they're just going to be larger. So we're going to work our way through this together. Okay, so we're going to do 9 times 64 to the power of 3 over 2. So 9 times 64 to the power of 3 over 2. So when you distribute, okay, you have 9 to the 3 over 2 times 64 to the 3 over 2. So what we talked about today is how that bottom number is a root. So this would be the square root of 9 to the 3rd power, and this would be the square root of 64 to the 3rd power. Okay, so the square root of 9 is 3. 3 to the 3rd power is 27. Okay, I'm going to help you with this one because it's a larger number. So it's 8. 8 to the 3rd power is 512. Okay, and you could figure that out without your calculator. You could figure this one out, but it would be a lot, and I wouldn't have you do something that large on the no calculator quiz. So I'm just going to tell you it's 13,824. Okay, but I did want to show you one where you wouldn't want to multiply right away, and so I had to use some bigger numbers. All right, and then the last one is another distribution of exponents. It's just with division. So if you have 8 over 27 to the 1/3 power, that would be equivalent to doing 8 to the 1/3 over 27 to the 1/3. And remember, the 1/3 power means the cube root. So what's the cube root of 8? 2. Cube root of 27? 3. So that would be your final answer. No, I'm simplifying because you have, this would be the cube root of 8, and that would be 2. This would be the cube root of 27, and that would be 3. Yep, so you distribute 8 to the 1/3, 27 to the 1/3. So you apply it to the numerator and the denominator. Okay, so based on those, I want you to try these. So 7 to the power of 7/9. You can do it. Okay, I'm going to have you try A and B. So if you have the same base and you're multiplying, what do you do with those exponents? Add, yep. So 7/9 plus 11/9 is 18/9, and 18 divided by 9 is 2, and 7 squared is 49. Wait. I'm not going anywhere. Well, let's not say that. Okay, and then for B, if you haven't subtracted already, can you do that and simplify? Okay, so once you have subtracted, what did we get as our exponent? Yeah, good. Okay, so negative 2/4, which will be negative 1/2. I'm going to write this here. Okay, so if you have 16 to the negative 1/2, we're going to put it underneath the 1, and then you can decide where you would like to go. If you keep recognizing that that's the square root, what's the square root of 16? 4, okay? If you are a visual learner, then you might like just seeing that square root, like writing it and then showing that, and that is fine too. All right, so then let's try negative 8 to the negative 1/3. So anytime you have a negative, that first step is 1 over. Okay, now the 8 stays negative. The only thing that becomes positive is the exponent. The only thing that becomes positive is the exponent. And then you can take the cube root. The cube root of a negative is going to result in a negative. Okay? All right, now we're going to do some that have a mixture of numbers and variables. And really, I think some of you could do this, so think about how we would simplify there. Okay, so I have a 16 and I have x to the 20th. So when we're looking at our rules, okay, what rule do you guys think that that would be on your chart? 1, 2, 3, 4, 5. I'd say it's more 4. Okay, and both of those you have a power to a power, but here you have those two terms. Okay, which means we're going to do 16 to the 1/4. And then let's just simplify this. If you do 20 times 1/4, that's going to be what? 5. Okay, and then the 4 through to 16, we're going to simplify. Okay, and a lot of you are going to know right away what that is. Okay, others of us are going to factor tree, and that's fine too. Okay, if you want a factor tree to make sure it's 2, you can always do that. Yeah, you can go right from here to here. You can go right from this step to your last step.
Will there be situations where it's not perfect like that? There's
There could be.
Oh, but then in that situation.
Yeah, in that situation, you'd have like a mixture of those. All right, now this one has a few different things going on. So when you have like multiple things, a negative exponent, parentheses, I like to just start with one step at a time. So what I would recommend is simplify the numerator first. Okay, and some of you are going to be able to do this right away. I just want to show you what's happening here. Okay, and we're just going to keep this on the bottom for now. So remember, 16 to the 1/2 is the same thing as taking the what? Square root. So it's just 4y to the 1/2 over y to the -3/2. Hold on, let me explain it, okay? So we're going to do one of our rules, and then I'm going to tell you another way you could do this if you wanted. So one of our rules is, if you're dividing with the same variable, what would you do with your exponents? Yep. So you could rewrite this as 4y to the power of 1/2 minus -3/2. And when you're subtracting a negative, it turns into a plus. Okay, so this comes from our second rule, where if you have the same base, you can do the top minus the bottom. It's just we had minus a negative. So 1 plus 3 is 4. 4 divided by 2, 2. So it becomes 4y squared.
So
just take a second to process. Okay, so when you have 1 plus 3, right, and that's 4/2, we're going to reduce. Yep, minus the negative. And then when you have a negative in the denominator, remember how whenever we have negatives, we've been putting it over 1? Okay, then instead, if it's on the bottom, you could just bring it to the top, okay, and you could add them together, and it would be the same thing. Okay, so you could think of it that way. All right, so you guys do this one. Okay, 64 to the -5/6. You can double check your first step with me. And really, you guys are going to get very good at this, and it's fine if you want your first step to be the 6th root of 64 and raise that to the 5th power, right? Because you know the one under is going to make that positive, so as you get more comfortable, you can do that. When you're thinking about what the 6th root of 64 is, just remember 64 is 8 times 8, and 8 contains 3 2's. Okay, so there's how many 2's altogether? 6. So this would be 1 over 2 to the 5th power. So your final answer, 1 over 32. All right, so you have your worksheet today that is due tomorrow. Okay, and we can get a lot done with the time you have left. Okay, you can get a few rows done.